push that rock with some math. Let's review the differentiation product rule. So if I need to take the derivative of f times g, then it's f times the derivative of g plus g times the derivative of f. Now, I'm going to differentiate both sides of this identity that we proved earlier this semester with respect to x. Over here, integration undoes the differentiation because integration is anti-differentiation. So I get f times g. Over here, since I have this plus and integration is a linear operator, I can separate that to f times g prime with respect to integrated with respect to x plus the integration of g times f prime with respect to x. Now, I'm going to subtract this over to this side. So I have f times g minus the integration of, I'll maybe change that order, f prime times g with respect to x. So I subtracted this over, and all I did was use the commutative property to rearrange it maybe. And then on the right hand side, I still have the integration of f times g prime with respect to x. And what we have here is a relationship that is called the parts formula. The integration by parts formula. So it says that if you're integrating a function times another function that is a derivative, which, you know, any function can be viewed as a derivative of another function, then the integration of that is the product of the two functions minus the derivative of this one, the integration of the derivative of this one times the g function integrated with respect to x. So there is the parts formula right there. You'll want to put that in your notes. Now let's do an example. So we see this parts formula in action. Now, here I have only one function, and so I've already run into a difficulty because the formula is for when you have a product of functions where you view one of them as a derivative. So I already have a problem, but that's okay. You can visualize a times one right here, and you can think of one of the functions as just a constant function, the constant function 1. So the two functions can be f, can be arc sine, and then g prime, remember you visualize the other function as a derivative, g prime can just be 1. Now in the formula we have to know f prime and we have to know g. So to get f prime, I would take the derivative, and we know the derivative of arc sine. You proved earlier in the semester, and hopefully maybe you run through that proof in your metacognition journal. But the derivative of arc sine is 1 over the square root of 1 minus x squared. Now over here, we need to know g. So to get from g prime to g, you have to anti-differentiate. Well, the function that we would take the derivative to get 1 is just the identity line, x, because the slope here would be 1, and if I take the derivative of this, I get 1. So the antiderivative of 1 is just x. So now I have my f prime, g prime, and g. I can use the parts formula. So the parts formula says, thinking of this one as there's supposed to be an f and there's supposed to be a g prime, and I'm thinking of the arc sine as f, and I'm thinking of the g prime as 1, and we're integrating that with respect to x, and it equals f times g Well, I'm going to put it in the other order. I'm going to go g times f because it's more polite to put the x in front. So I'm going to have x times the arc sine of x minus the integration of f prime times g. So I'm going to, when I multiply this by this, the x ends up in the numerator because, you know, this is x times 1 is x, and 1 times that square root is that square root with respect to x. So there's the formula. I used it. Now I haven't found the antiderivative because I still have this antiderivative in here that I need to find. But we're well on our way. And this, we already have a technique for integrating this. We can see clearly that there is a quadratic in the denominator, and the derivative of a quadratic is a linear function, and there's a linear function up top. So clearly the way we're going to handle this is with u substitution. So let's copy this down on the next page. So we need to deal with x times arc sine of x minus the integration of x over the square root of 1 minus x squared to dx. But to handle this, we're going to let u equal 1 minus x squared. That means the differential of u, remember, is the derivative of this, which is negative 2x. The 1 goes to 0, and then you get a negative 2x here, times the differential of x. That's the definition of the differential of u. You take the derivative of the function and then multiply by the differential of x. Now, my function doesn't have a negative 2. It has a negative. So maybe what we could do is change that negative to plus a negative. So now that's a little closer, but we still have a 2. What could we do about that? Well, we could change it to plus 1/2 of negative 2x over the square root of 1 minus x squared dx. Yeah, then we could take this du and substitute it in for negative 2x dx, which is the whole numerator. Oh, that's supposed to be an x. So I'm going to change this to put a half here and make that a negative 2 there. So I can put in du for the numerator there. And then remember, we let u be 1 minus x squared, so we have the square root of u. And that's what this, and it's plus 1/2 times that. So that's what this portion is going, we're going to anti-differentiate this with u sub. And I still have the x arc sine out here, x, but we'll move to the next page. So here we go. We know that we can substitute now. We have, instead of writing du up top, I'm going to write it as 1 du this way. Okay, so it looks like integration. And then the square root of u here. Now, how are we going to handle that? Well, we're going to handle that with the power rule of integration. We're going to rewrite that as u to the negative because it's in the denominator, and 1/2 because it's a square root, du. And then we have 1/2 times, you add 1 to the exponent, which gives me 1/2, and put the reciprocal of the new exponent out front. And then you add your plus c, so we won't forget that. And don't forget we still have this down here. But we don't want u. See, we have x's. So remember, we're trying to integrate arc sine of x with respect to x. So we don't want a u talk. So we have this x times arc sine of x plus 1/2 of 2 goes away. U raised to the 1/2. Well, that means I have u square rooted because raised to the 1/2 is the square root of u. But remember, what was u? Oh yeah, we let u be this radicand all along. We let u equal 1 minus x squared. So we can interchange u with 1 minus x squared. And don't forget your plus c, baby. And that's how you use the integration by parts formula. Math made simple, Simpson math.